At times you may need to estimate the standard deviation. A quick way to get an estimate of the standard deviation is the range rule of thumb. And for reasons we will understand later, 4 times the standard deviation will usually include most, if not all, of the data values. So the standard deviation can be approximated as the range divided by 4, since the range includes all of the data values. So to estimate the standard deviation, using the range rule of thumb for the set of data 21, 33, 45, 51, 67, 72, and 80, we would find the range, which is the maximum value minus the minimum value. And remember, standard deviation is denoted by lowercase s. And since we're approximating, we're going to use the squiggly equal sign. Range is the maximum minus the minimum, and divide that by 4. So 80 minus 21 divided by 4 is 14.75. And just like you'd round standard deviation to one more than the original data set, one more decimal place in the original data set, so that would be 14.8. So if they say use the range rule of thumb to find the standard deviation, that's just the range divided by 4. A common application of the range rule of thumb, if the standard deviation is known, is to use it to determine maximum and minimum usual values. If the range is approximately equal to 4 times the standard deviation, and we can assume the mean is approximately in the middle of the range, then we can draw the following conclusions. 1, that the minimum usual value is equal to the mean minus 2 times the standard deviation, and 2, the maximum usual value is equal to mean plus 2 times the standard deviation. Now in notation, that would be x bar minus 2 times s, or x bar plus 2 times s, and that is for sample, mean, and standard deviation. If you want to write that for population mean and population standard deviation, mean is sigma, and that would be mean is mu, standard deviation is sigma, mean is mu, minus 2 times sigma, that's for the minimum, or for the maximum, mu plus 2 times the standard deviation, which is sigma. So the concept of maximum and minimum values or usual values is very important. A pulse rate for a woman that is above or below the usual values might be a cause for concern and instigate a deeper investigation into her overall health. So, for example, pulse rates have a mean of 76 and a standard deviation of 12.5. Find the maximum minimum usual pulse rates. Is a pulse rate of 105 considered unusual? So this question asks you to find both values and then compare it to a certain rate. Some questions will just ask you, is this value considered unusual? That's a key phrase to let you know you need to find the maximum and minimum usual values and then do the comparison. So first, a maximum minimum usual value. So the minimum usual value would be 76 minus 2 times the standard deviation. A maximum would be 76 plus 2 times the standard deviation. Computing those values, that would be 51 for the minimum and 101 for the maximum. Now, to compare that to 105, is a pulse rate of 105 considered usual? The answer is no. Since 105 is greater than 101, it would be unusual. So I'm going to draw a little number line here. Here's our mean, and mean plus 2 standard deviations, though there's 2 sigma. Mean minus 2 standard deviations, so there's our negative 2 sigma. Anything within that is considered usual. Now, for this, our values were 51 as a minimum usual value and 101 as a maximum usual value. The value that we were comparing was 105. So it was outside that interval of values. Anything in between those would have been considered normal or usual. Outside, unusual. So our second step on this problem was to do that comparison, and then we would actually write something like, since 105 is greater than 101, 105 is not usual.